Okay, this is the beginning of our lesson for 8.3 homework. Have a review to go over. You don't need to write any of this down, but just watch and answer the questions that I ask. Okay, you should remember a standard form before of a quadratic, ax squared plus bx plus c equals 0. What does the a tell us? That's my first question. What does that tell us? An answer would be, first of all, if it's positive, it will go up like this. So it looks like a little happy parabola. He's smiling. And if it's negative, it would go down like this. Now, if this is a positive value between, let's say, it's close to 0, so it's like a fraction. So it would be like maybe 1/8 x squared. What would that do to the shape of the parabola? Hopefully you realize that would flatten it out like this. But you'd still be happy. Now, what if this was a value more than 1, positive, like let's say it was, I don't know, like maybe 10 or 3 or something like that? It would make the parabola more steep. Okay, so it would make it steeper. And the same thing if it was a negative value between, let's say, 0 and -1, and the closer it is to 0, the flatter it is, so it would do like this. And let's say it was like -3, it would be like this. It would be steep versus the parent function of just like a regular negative x squared would look something like this. So you see that steepens it as the value gets farther and farther from 0. Okay, so graphing by hand of a quadratic formula. Do you remember what step 1 was? If we have to graph this by hand, what was step 1? We find was it axis of symmetry, or did we find the vertex? It was axis of symmetry. And that was the value. In other words, you might, if you answered, we need to find x, you are right. So you need to find x equals something. And what did you use for that? You used the formula x equals negative b over 2a. So that gives us the axis of symmetry. Then what was the next step we needed to find? Do you remember that? So step 2 was find the vertex. And what did we use for that? We used f of negative b over 2a for whatever quadratic formula we're working. And like we'd find this and say x equals a 3, then you just plug a 3 into that, and every place you see the variable squared and the variable to the first power, you'd put in your 3 or whatever it would be. Then you plot 2 points. You plot 2 points to the right, so like 2 points to the right or 2 points to the left, and you get a symmetrical design. Now, one thing I want to point out is I noticed on some of the homeworks, I noticed things like this for your parabolas, and this may have just been an oversight. What I saw some parabolas going almost straight up and down, and one side was curved out. Now, you would never have this because this means like x repeats. And you remember the straight line test? We do the straight line test, and so x can never repeat. Otherwise, it's not a function. So it would always have a little bit of a change here. You see, obviously, that there, the x value changes. It gets further negative, and up here, it gets further positive. Now, if it gets really, really steep, it may look like it does almost go straight up, but the value of it going out might be very, very small. In other words, like say from this point to that point, like this one might say, let's say if this is our axis of symmetry on the x-axis, we might say this is 1, and that's 1.002 or something like that. But it will always be a different value. Okay, today might be a little bit of a long video because I have about 10 examples to go through once we start our homework examples. So you might want to watch this video in a couple settings. First thing we want to look at today is we want to explore the vertex form of a parabola. And why do we want to do that? Because it's a lot easier to graph it than using all of this. So there's an easier way to do it. Okay, so think of a graphing form of so think of it vertex form, think of it like it's the graphing form of a parabola. And to remind you what in the world this does and relate it to something we've done in the past, do you remember how we used to graph absolute values when we had a parent function was y equals absolute value of x? Do you remember that? I said always make those absolute values look big and thick so it doesn't look like 1x1. You may or may not remember that, but I'm going to go through it again. And this parent function looked like, if this is my x value and this is my y value, it started here at the origin and went up there at a 1-to-1 and also had one over here. And they were straight lines. Hopefully you remember that. And remember also how we studied the transformations of it. Now what I mean by that is how it changed around. Like we could have a graph that looks like this. Well, what we used, if you remember, was y equals a absolute value x subtract h absolute value plus k. Now what did some of these things do? This here moved the vertex, so that pointy spot is the vertex. It moves the vertex left and right opposite of what you would think. So in other words, if we had a negative, or excuse me, a positive h, it would move it to the left h units. And I'll show you what I mean by this in case you're like confused at the moment. And if it was a negative h, it moved it to the right h units. And k, I used to use a v in class because it moved it vertically. If it was positive, it moved it up. And if it was negative, it moved it down. Now let's take a look at what the A did. Well, the A does the same thing that it does with the quadratic formula. If A is positive, it goes up. And if it's negative, it goes down. And it also does the very same thing that the A does up here. As far as it's a large value, it makes it very, very steep. And if it's a really small value, let's say it's like close to 0, like let's say A was 1/32 or something like that, it would be a very flat. And if this was 0, it would make a flat line. But remember, this A does not transfer through here. So we don't do the distributive property. Never distribute things through an absolute value problem. Okay, let's take a look down here at what we're going to be doing today. My kitty cat is on the, oh, that's his kitty cat tail. He likes to do math. Maybe one day I'll be able to show him. So we'll be looking at this formula right here, which is y equals a. Now that's a parentheses. So that means the A can distribute through there. And also notice it's squared, and we have plus K. Well, in class I would normally use a plus V because that's how it moves is up and down, and this was horizontal. So our lesson today is how to change from the quadratic formula into this, and how to graph this type of a problem. Before I went on with our lesson, I just wanted to review in case you needed to see it. Just watch this here. You might be able to speed up the video. This is a graph of the absolute value of x. This is the parent function. Okay, now this one has been changed around. Okay, so hopefully you remember that this, the h and the k, this was opposite x, and this was the y. That's the y of the vertex. Okay, so if we look right here, that point I have, graph from this absolute value, is -2, -3. Now the A shows our slope or how steep it is. So if we look, that's up 1 over 1, up 1 over 1. So in this case, A equals 1. So we're not going to put it in our formula because it's implied. So if we take this and looking at our graph, let's see if we can find the formula for that. I'm sorry, not the formula for that, the equation. So A is 1, so we don't need a 1. I need the absolute value of x, close absolute value. Okay, now this is opposite x, so it's, I see it's a -2, so I'm going to put plus 2, because remember that's opposite. That's just the way it works. Now for the k, it's going to go down 1, 2, 3 units, so down 3 units. So that is the equation for this absolute value graph. And we're going to be doing things similar, but with the parabola. It works close, but not exactly the same, but it works really close. Okay, let's take a look at this one. Okay, now that's upside down. So that's going to give me y equals a negative. Okay. Now we find the slope on the right-hand leg. So this is my right-hand leg. So that's down to the right, down to the right, down to the right. So that's a negative. I don't need the 1 because it's implied to 1. Absolute value. Okay, I always need my x there. Absolute value. And what is that point right there? That point looks to me like that's 2, 4. And this was x, this was y. So remember, it's opposite x, so that would be a -2, and up 4, so plus 4. So there's what this equation would be. Okay, now let's take a look at this one here. All this slope here is a little different. Notice it's steeper. So what's the slope of the right-hand leg? The right-hand leg. Go up 1, 2 to the right 1, up 1, 2 to the right 1. So that's 2 over 1, or I could say m, or my slope equals 2. Well, in this case, since it's not a linear function, it's a absolute value, I would say y equals 2. Absolute value. Then comes my x. Now what's that vertex? That vertex looks to me like it's -2, -4. Okay, so opposite x, so plus 2, close absolute values, and subtract 4. So that's what this equation would be. And you can check that if you want to by putting this into your graphing calculator. And you'll need to change your window to square, and it would match up just like this. Okay, let's take a look at one more here. All right, that's upside down again. So that's going to be y equals a negative something. Look at our right-hand leg. So that's down 1 to the right 2. So down 1 to the right 2. That means my slope is a -1/2. Notice it's flatter because it's closer to 0 than this one was. Absolute value x. Now I need that vertex right there. So the vertex was -2, 5. So I need opposite x, so plus x, so plus 2, and then I put my y value in exactly as I see, plus a 5. All right, here comes Kitty Kitty again. Makes it hard for me to see. Kitty, you're going to have to leave. This is Kitty Kitty. He likes to help us with our homework. His little nose right there. His name is Gizmo. Gizmo loves to play and help us with our homework, doesn't he? All right, let's take a look at this here. Now we have an equation. Let's see if we can figure out what this would be to graph it. Okay, so remember, this is my x, but it's opposite x. So I go to -4. So there's -4. And we go down 5. 1, 2, 3, 4, 5. So my vertex is right there. Okay. Again, so opposite x, to the left 4, and down 5. Now this is my slope. So my slope is 3 to 1. So up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. So that means I have a graph that looks like this. Grab my straight edge really quick. So my right side is really steep, and my left one would look just about, it would be a mirror image. It would go off the graph on that side. So that's what it would look like. Okay, so that's a review and shows us the absolute values and how they transformed around. So now we're going to look at the quadratic equation and how it transforms around. But first we got to know how to change it into standard form, which is really easy. So if you haven't already, get out a piece of paper because now we're going to start taking notes. Okay, this is Gizmo. If it'll hold still, figured some of you probably wanted to see what he looked like. So here's a little break for you. So this is Gizzy. We got him at a shelter. Find some really good kitty cats at shelters. Okay, so this is our notes. So this is notes for Unit 8-3 homework, okay? And this was on vertex form. Vertex form of quadratics. So if you don't already have paper out, get some out now. Okay. So the vertex form of a quadratic looks like this. It could be y or f of x equals a parentheses x subtract h parentheses squared. Now don't forget that square. That's very important. Plus k. I like to use V for vertical, but hopefully this is the way it is in books, okay? Now for this, the cool thing is this gives us our vertex of our parabola, and so I want you to think opposite x, okay? Because that actually gives us our x and y coordinate of the parabola, well, the x coordinate, and right here, this is the y coordinate. So this is the y coordinate. Guess who's back? Kitty Kitty. He likes to jump up on my desk. Little feller, you need to get down. All right, so let's take a look at this. Now, sometimes we have this in, if we have h and k, and again, so this is opposite x as it comes from here. But when we put it in here, we'll fix it. This is our x and our y of our vertex. Our O-U-R. Vertex, where the h equals opposite x, and the k equals the y, whatever it happens to be. All right? Okay, so this is our first example here. So write that down. Y equals, parentheses, x plus 4 squared, subtract 2. First thing we want to do is find the axis of symmetry, and we want to find the vertex. The cool thing is we can find these without even bothering to graph it. All right, so axis of symmetry, AXIS, Mr. T. So axis of symmetry is, remember that's the value of x, so it's at x equals opposite, so a -4. So that's your axis of symmetry. Now remember, if you know how to read this, your vertex is here. Vertex is opposite h and k. Hopefully I didn't like upho, but that's opposite h and k. So that means my vertex is going to be, k is my y, so it's a -2. Okay, this is my x, but it's opposite x, so that would be a -4. So that is my vertex. Okay? Okay, here are our next 3 problems we're going to work. So if you want to pause the video right now and write those down, you can. Alright, so we need the axis of symmetry, okay? I don't see a plus anything here, so it looks like my vertex is going to have a 0 in it because it's not there. Okay, so what's my axis of symmetry? Remember, that's like x equals something, right? So that would be x equals what? It's right here. Don't let that fool you. I know some of you want to distribute that through there, but remember, we just read it from how it is there. So that's opposite of a -3 would be a +3. And then what's my vertex? So remember, that's my x, and it's opposite, so it'd be 3, comma, I don't see anything there, so it's plus or minus 0, we could say. So my vertex is at 0. If you need to play that back, go ahead. Okay, let's take a look at example 3. All right, what is my axis of symmetry? Remember, it's here, so it's opposite. So it would be x equals a +5. Then my vertex, x would be the 5, and then there's my y, so it's a +4. No, a -4, -4 right there. Okay. Remember when you're writing this down, don't forget the square. Okay, now let's take a look at this one. It's a little different how it's written. Okay, so what's happening here is we could rewrite this as like a -2 x squared plus 3. Hopefully I'll let you see where things is. So this is your value of a over here. I don't see anything added or subtracted. So what's my value of x going to be? So x equals what? Remember, here's a hint if you're confused. That's the way it could be written, but we don't bother to write it that way. So what's x equal? X equals 0. Good. Okay, now our vertex. So it's not there. And remember, they'll give it to you like what's here above my finger. So that's going to give you a 0, comma, +3. Okay, now just in case you think, oh, things are going to get easy now, please stay with me. I got just a few more examples to work through. Okay, so this is our next example, number 5. Now notice I numbered my paper. This is notes 8-3. This is paper number 2. And these here we want to graph them, okay? All right, so let's first figure out what we have here. What is my axis? Remember, that would be x equals something, and my vertex is the x and y value, okay? This negative, because I'm going to have to graph it, means my graph is going to go upside down. So it's a good idea to make a little sketch of what that'll look like. So it's going to look like this, and it's going to have the shape of a parent function because that's considered a 1. All right, so let's find out our axis of symmetry. It's right here. So is it positive or negative 2? So it's opposite, so it'd be a negative 2. So if you got that, that's good. And we can put it right here. What's my value of y? It's right there. There it is, 7. Okay. Now, I noticed that a lot of you had graphing paper. So I'm going to actually pull out some graphing paper here. And so I'm going to see if I can graph this one here. And what would this look like? Okay, so I have a vertex at negative 2, 7. So negative 2, 7. Oh, and it's not going to fit on my paper. That's going to make it difficult. So it's going to be way down here. All right, something like that there. And it's going to go, no, positive 7, Mr. T. So way up here, it'd be way up here at the top. Okay, so what I've decided to do here was go ahead and graph it with a hand graph. This is good practice because we don't always have a graph, though you will on your homework. Okay, so let's see, I want to go up 7. So 1, 2, 3, 4, 5, 6, 7, and to the left 2, 1, 2. So I'm estimating it should be about there. Now, you will have graph paper that you can download. Now, if you can't download, do your homework by hand. But if you can get it, graph it, and do it as best as you can, and put the dots in the right place. Don't just put them willy-nilly. There has to be a logical sequence. Okay, now I know it should go down like this. All right. So I'm going to use a table, and I'm going to use probably the right. I'm going to use a -1 and a 0. I'm going to find out what the right side of this looks and how steep it goes down. So I'm going to use function notation, and I can use this graph up here, and it should work. I'm going to pause the video and pop it back, and you can see what I've done. Okay, I want to work that out ahead of time, make sure I don't have any mistakes. But what I wrote was f of -1, and I put it into my original equation. Now we have to be careful here because we have parentheses and parentheses, so I have to put that in there as a -1, so that's inside the parentheses. So you could say, well, that's just -1 plus a 2, so that shrinks down to just a 1, and now that's squared. So 1 times 1 is 1. The negative stays on the outside. Bring the 7 down. So that gives me a -1, 6. So I should have a spot at -1, 6. 1, 2, 3, 4, 5, 6. So about there. Now a mirror image, I would have one the same distance apart. It'd be nice if we all had pretty graph paper, but we don't. Let me bring that up and that one a little larger. Okay. Now the next thing I'm going to do is find f of 0. So I'm going to plug in f of 0. And so that's going to give me 0 plus 2 squared plus 7. So -2 squared plus 7. Pause the video if I went too fast there. So this is going to give me a -4 plus 7. The nice thing about having it on video is you can pause if I'm going too fast. 4, 5, 6, 7. So that's going to give me a 3. So f of 0 gives me a 3. 1, 2, 3. So about there and about there. Then I can graph. Remember, it's got to be a curved line. And it's best to use little bitty strokes so you can get it to fit in there. All right. So it should look something like that. Okay. Now we can do our domain and range. So remember the domain, which one is that? Is that X's or Y's? Do you have a way to remember that? I remember range is Y's, okay? So that value, 1, 2, 3, 4, 5, 7, okay? So Y and a 7. It's less than and it's equal to. So less than looks like a sideways L and equal to. Now some of you guys are doing a different notation. I noticed that on your homework the other day. So go ahead and do this. Make sure you understand what I'm doing. So the range is Y is 7 or less or equal to. And then the domain is all real numbers. So all you need to do is put this. Okay, double strike R for all real numbers. You can write infinity to infinity if you want. Okay, here's my next example. I tried to bring my work up a little bit closer so I wouldn't use so much paper. And let's see what we can find first. You might need to write it down. So this will be x equals something, and right here will be my x and y value. Alright, so look at them here. That's my a value. This is opposite x, so that would be a positive 1. So put a positive 1 here. I don't see anything written there, do you? So what's my vertex then? 1, comma, what is it? If it's not there, it's 0. Very good. So 0. Alright, so now let's see if I can get my vertex here. Oh, what's this going to look like? It's going to be right side up. So it's going to be right side up like this. What is the 3 going to do to the shape? The 3 should make it look kind of steep. So make it kind of steep versus the parent function is wider. Alright, so let's see if I can put a graph over here. My vertex is at 1, 0. So x is 1, y is 0. So my vertex is right here. And by the way, we do have an axis of symmetry that goes through the middle. We didn't talk about that. The one above does have an axis of symmetry that goes right through there and hits the 2. We did talk about it, we just didn't graph it. Alright, now I'm going to find 2 values to the right. So that's 1. I want to find f of 2. I'm going to find that. And then I think after I do that, I'm going to find f of 3. So I want you to stop the video and see if you can do that. And then when you've got it done, pop it right back. Okay, so here we go. Hopefully put in f of 2. So where we have the x, we put in a 2. Then we just do the math. On the inside, it gives us a 1. And then it's 1 squared is just 1. So 3 times 1 is just 3. So that means I have a point at 2, 3. So I'm going to go over here at 1, 2, 1, 2, 3. I have a point right there. So it means opposite, I have one over here. Because remember, it's a mirror image of my axis of symmetry. The next thing I plugged in was f of 3. And so I put that in here. So 3 subtract 1, remember the square. So this is going to give me 2. And 2 times 2 is 4. 3 times 4, that's not right. Okay, so 3 times 4 is 12. See, don't be upset if you make mistakes. That's where we learn. I've been doing this for years and I make lots of mistakes. Okay, so 1, 2, 3. I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to look like this. And opposite that, then I sketch in my curve. That's pretty steep there. It looks almost like an absolute value, but it's still got a curve. So it should look something like that. Okay, now notice how much steeper that was. Looks to me like it's steeper than that one up there. Okay, so what's the domain and what's the range? Range is the y's, all right, so that's y. What's the lowest point? 0. It's going up from that, right? So my graph is greater than 0. So y is greater than or equal to 0. And the domain, of course, is all real numbers. And some students ask, will these always be all real numbers for a parabola for the domain? And the answer is yes, if it's not a piecewise function. Okay, now for 7, 8, 9, and 10, we're going to do something a little different. We're going to look at how the graph changes from the parent function, okay? So the parent function is the easiest. And that's y equals just x squared. So the a would be 1, b and c are 0. This is known as the parent function. Okay, and what is a transformation? So the transformation is a change to the size or position of a figure. So change in size or position of a figure or a shape or a graph. Okay, so here we're going to do example 7.